We're not going to have to do anything crazy, go nuts, like our Cramer's rule, elementary row operations to solve these systems. These are all basically substitution and elimination. Now, depending on the problem will affect if you should use the substitution and elimination. They'll both work, just you might as well pick one that's easier for you. So let's solve this one. X squared plus y squared equals 9. And x squared minus y squared equals 1. Of your two methods, elimination would probably be the lot easier for this one. The way you can tell is because we see common terms in both equations. Both of them have x squareds, both of them have y squareds. And notice one y squared has a positive coefficient of 1, the other one has a negative 1 coefficient. So we're going to use elimination here. Using elimination, remember you just need negative coefficients, which we already have. So remember the first rule would be multiply one or both equations by non-zero numbers, so when you add them, a variable goes away. So if we straight up add these two, what happens to the y terms? It goes away. Now please be careful. X squared plus x squared is 2x squared. 9 plus 1 is 10. Now, most students have great intention with this, but when they write x squared plus x squared, they write x to the fourth. You're not multiplying them, you're adding them, so please be careful. So to solve for x, what are we going to do? Divide by 2, so we'll get x squared to be 5. And now when we square roots, what do we get for x? Plus or minus the square root of 5. Okay. So now we're going to put x equals the square root of 5 into either of the original equations. Then we're also going to have to do x equals the negative square root of 5. So let's start with the positive one for now. Does it matter which equation we use? Nope. Let's use the top one, because y's got a positive coefficient there. So we'll have square root of 5, then squared, plus y squared equals 9. What is the square root of 5 squared? If we subtract the 5 from both sides, we'll get y squared equals to 4. So y will equal plus or minus 2. Is that okay? Good. So this gives us two ordered pairs. In both ordered pairs, x is positive square root of 5. One y coordinate is 2. The other y coordinate is negative 2. One more time, please. We're going to have 4 answers here, yes. The other one, we'll put in negative square root of 5. But notice after this step, it's just like what we did before. Because negative square root of 5 squared is positive 5. Subtract both sides. You get y squared to be 4. So we're again going to end up with plus or minus 2 for y. So your coordinates both have a negative square root of 5. But now one's a positive 2. And one's a negative 2. Please keep your answers separate. What I do not want to see is plus or minus radical 5, comma, plus or minus 2. That's bad. So as far as what did we just do, what is that first equation if you had to graph it? It's a circle of radius 3. What's the second equation if you had to graph it? Hyperbola. A and B are both 1, because we're dividing by 1 here. So this box is really a square. And it's going to be horizontal. So if I plotted this, it looks something like this guy. So what these 4 points represent are the 4 points of intersection of the hyperbola and the circle. Or a very poorly made baseball. One of the two. Hooray! Class time. Alright, so as a comment, there's no way really without drawing a graph of knowing how many exact answers you would get. So when we did elimination way before, you either got one answer, infinitely many answers, or no answers. Here we got 4. We could have gotten just 2. We could have gotten just 1. Could have gotten none.